Hello student, in this video we have first one of additional exercise problem of chapter 5, 5.16. There are few questions. First one is, why does a paramagnetic sample display greater magnetization when cooled? So to answer this, let us first see what is paramagnetic substance. Paramagnetic substance is the one in which you have dipole moment existing at atomic level. So each atom is having net dipole moment. So electronic motions, orbital motions of electron are in such a way that the resultant dipole moment due to all the electrons in their orbital motion, due to orbital motion, is not cancelled out. Okay, and hence each atom is possessing some net dipole moment, and so paramagnetic substance is described like this. The circles are indicating atom and the arrow is indicating direction of dipole moment. So this is the standard way of describing a paramagnetic substance. And why arrows are randomly oriented? Because in absence of external magnetic field there is no net magnetization. Now what happens when you subject such substance to external magnetic field? Suppose I apply external magnetic field. What will happen in that case? Suppose I have north pole left, south pole here, and so magnetic field lines are going like this. So what will happen? In this case, you have some atoms which will be readily aligned with external magnetic field. Say this 4, and then the condition will be like this, and then you have some level of magnetization achieved. Now suppose if you increase external magnetic field, if you increase the external magnetic field, you are aligning a few more. So the magnetization will also increase. Okay, but you will always have a few which will not be aligned because they have external thermal energy at room temperature. And so what happens is that as you increase temperature, the randomization of such atoms increases. Okay, and hence with increase in temperature, randomization increases, magnetization decreases. On other way, if you cool it down, then you are depriving them of their thermal energy, and then the magnetic potential energy will be more than the thermal energy, and then you will have more magnetization. So cooler paramagnetic substance describe higher magnetization compared to paramagnetic salts or paramagnetic substance at higher temperature. Second one, why is diamagnetism in contrast almost independent of temperature? Now here again, what is diamagnetic substance? Diamagnetic substance is the one in which you have this kind of situation prevailing. What is this? Inside the atom, if one electron is having dipole moment in this direction, the other one is having dipole moment in opposite direction. So what is the net dipole moment of diamagnetic substance? 0. But this is in absence of external magnetic field. Okay. So if I have to describe any diamagnetic substance, I'll show just atoms, no arrows. Why no arrows? Because there is no net dipole moment. Okay. So this is diamagnetic substance. Now what happens when you subject it to external magnetic field? Because of external magnetic field, the electronic motion in this orbit are modified. Okay. And then the condition will be something like this. What happened now? Look at this too. Here, in previous case, when there was no field, the dipole moments were equal and opposite, so resultant was 0. When you apply external field, the electron's speed changes, and hence one dipole moment decreases, other one increases, and now net dipole moment is no more 0. And this is called induced dipole moment, and induced dipole moment will always be opposite to the external field. So in presence of external magnetic field, these atoms develop induced dipole moment, though the value of induced dipole moment is very less. But obviously, when you have zero magnetization, this less value is also observed. Okay, and this induced magnetization is always opposite, but it has nothing to do with the random motion of this atom due to temperature. So you increase temperature, you decrease temperature, but this induction or induced dipole moment will always be opposite to the applied field. So change in temperature won't affect this phenomenon, and hence diamagnetic susceptibility does not depend on temperature. Its magnetization has nothing to do with temperature. Next one. If a toroid uses bismuth for its core, will the field in the core be slightly greater or less than the empty core? Now, bismuth is diamagnetic substance, so what happens? When you subject it to external magnetic field, the field value induces dipole moment, which gives rise to magnetization in opposite direction, and hence the resultant magnetic field inside decreases. The magnetization is less, and hence change in field is also less, but there will be change, and there will be decrement in the field due to bismuth. Next one. Is the permeability of ferromagnetic material independent of magnetic field? If not, is it more or lower at higher field? Now, for ferromagnetic substance, uh, the external field does affect permeability, and higher the field, more the permeability. Next one. Magnetic field lines are always nearly normal to the surface of ferromagnetic substance at every point. Why? Okay, now see, for a magnet, if this is a magnet, the field lines will always go from north to south, and we know that magnetic field lines don't intersect each other. So if you look at the local part, locally the field lines must come out perpendicular to the surface, and this is true even for any iron piece, ordinary iron piece, because when it is responding to external magnetic field, it becomes magnet, and as field lines cannot intersect each other, it has to be the case where field lines are perpendicular to the surface locally. If they are not, suppose if I consider here one field line to be going like this, then obviously these two will intersect, which is not possible. Okay, so as field lines don't intersect, if you press them back, you will see that the field lines are always coming out perpendicularly to the surface. Next one. Would the maximum possible magnetization of paramagnetic sample be of the same of magnitude as the magnetization of ferromagnet? Now, this is paramagnetic substance. Is it possible to align all dipole moments? Yes, it is possible, and in that case, magnetization will be very high, just like ferromagnetic. But it is theoretical. Practically, you will have to apply extreme high external field to align all the atomic dipoles. And if you can do it, then yes, you will get very high magnetization, just like ferromagnetic. So that is all for this problem. Thank you.